Unit 7.3, Traversing Array List. Traversing Array List. So we're going to look at a couple of things here. And here's the list of things we're going to look at. First, we're going to make a list of integer objects. Remember, an array list only holds integer objects. And then we're going to take a look at autoboxing, which is turning a primitive into an object. Unboxing, turning an object into a primitive. We're going to use an index loop. Traverse the list. We're going to go forwards and backwards. We're going to show out of bounds error. We're going to remove some objects from the list. We're going to add some more objects to the list with a random generator. We're going to show the concurrent modification exception with a for each loop. When is it not okay to use a for each loop? And then we're going to use an iterator to traverse the list. Not on the AP exam, but very nice to know. So here we go. First up, the list of integers. Look at this, parameterized list. List of integers, not any mambo jumbo list, a list of integers. Well, here is autoboxing. The first statement is what happens all the time when you add an integer. Because it only takes object, we need to write the keyword new and a constructor, and this is a non-default constructor. It's a wrapper class like we saw earlier, and a 1 is in here, so it wraps the 1 into an integer object and it adds it to the list. However, you could write this statement this way, okay? And that's what autoboxing is. If I put the int here, it would create this and wrap it for me automatically. Autoboxing, see, turns the int 1 into new integer 1. Second, after adding, I hope you just realized that these two statements added 2 1s to the list. So right now at position 0 there's a 1, and at position 1 there's also a 1. So what if I want to get those things back out of the list? Not actually change the list, but tell me what's in position 0. I call the getter. I get at position 0, it sends back an integer object, so I can save it as the first value. Second value, though, I want to save it as an int. See, no problems here. Why? Because it unboxes it for me. It turns the integer object back into an int, so I could save it. So I'm flexible here. I could either save it as an integer as it is, or save it as an int and let the system unbox it for me. Okay. So right there we have some autoboxing and some unboxing. And then at the bottom here, I simply add some more things to the list. Realize I'm not using the first way to add, because that's a longer thing to type. The unboxing and autoboxing is giving programmers a shorter way of doing the same thing. Okay, so I'm writing it this way so it can box it up for me and add them all to the list. Then I printed the list. Then I created a random number generator, and I'm adding 5 things to the list. 5 random numbers, and all the numbers I'm adding are from 0 to 10. Remember, next int 11 is from 0 to 10. And then I printed the list again. Now, one of the things that happens a lot here is a lot of people make the mistake and writing list.size here. So for example, this, copy. I'm going to erase it, but I'm just going to show you what I mean. This is not okay. If you're adding to the list, you can't use the size. And you may say, well, why? Well, first, if you just made the list and you wrote this loop to add things to the list, the size is 0. And 0, which is where I started, is not less than 0. This loop would not run. But even if we add some things in here, right, it's still okay to add like this, but sometimes you want to add with a loop. If you're going to add with a loop, you still can't use this because the size might be big, yes, but when I add, the size will keep adding, right? Because remember, it grows and shrinks. So if I keep adding, the size gets bigger, and so I'll never reach this. So this becomes an infinite loop. So either it won't run if it's empty, or it will run forever. So we can't use the size when we are adding to the list. Be careful. Now, that doesn't mean it's true in all situations. Of course, we can come up with a case where it's possible to do it, but not with the same list. Maybe we have another list, and we're trying to add as many things in a next list as in the list before. So that size won't change. But if we're adding to the same list and using the same list size, it won't work. Okay, so back to 5. Now you could see this is going to add 5 things in here. And then I'm going to print the list. So I'm going to print it first above here, and then I'm print it again. Let's run that, see how it looks. And we'll take a look at what happens. Of course, we have it down here. 1, 2, 1, 1, 2, 3, 4, 5, like we added, and we added some random numbers. Now we added 5 more, so this could be any numbers. And that's the print there. Next thing we're going to look at is traversing the list forward and backwards. Okay, so let's go ahead and look at that. I have everything all set up here so we can walk through them. Here's forward. Start at 0. Stop at list size -1. I know you don't see the -1 here, but remember it's less than. That means the last guy that's going to run is this. Be careful. You cannot run this to all the way to size, okay? We have to stop one before. Same is true when we're going the other way backwards. We're starting at list size -1, stopping exactly at 0. Okay, so greater than or equal to. Make sure we get these things clear. Minus minus for backwards, plus plus for forward. Let's run this and see. Here is the list. Forward is printing exactly what this is. Okay, and backwards is going this way. Okay, so it's 7, then 0, 7, then 0, then 4, and so on. So we got to be careful. Now, because I mentioned these, I'm going to run right back into the errors concerning these two. Okay. So what are the common errors? Well, the common errors are trying to write something like this, but writing the thing so it goes out of bounds. Look, checking this guy forward. I'm trying to write forward, but look at my mistake right here. Okay. Less than or equal to. That equal to, big mistake. Because it's going to take me right to the size. I'm going to run it and let it crash. Once I get to the size, it's going to crash. See, out of bounds because the index is at 11 and size is 11. This should never be. The index and the size can't be the same. The index has to be one less. The very last index I'm speaking of, the edge case. The last index must be one less than the size. So if the size is 11, this needs to stop at 10. That's the reason why this guy above worked, because he says less than, not less than or equal to. Same is true here. Let me comment out this guy to show you that this one would crash as well. Well, it will crash right here, right? Because when we start off at size at this thing and put it in as I, whatever the size is, we can't print that one. So let's go ahead and check that. Crashes again, same reason. Can't access an index at size. Be careful with those and be watching for those because those are common errors. All right, let's remove some stuff from the list and let's add some more things to the list. Let's do that. So we're going to remove all the even numbers from the list. Anytime you remove from a list, go backwards. Let that sinking. Let that one sinking. So if I say remove something from a list, go backwards. This is the backwards code. Look at how it looks. So might as well, you could even just memorize it. It's that common. So look at this one up here, backwards. List size -1, that's where we start. Greater than or equal to 0, minus minus. You're going backwards. Now, why am I going backwards? Because when you remove something from the list, this stuff shifts to the left. So if I went forward, I might miss something, right? Like if two values are right next to it and both need to be removed, when I remove the first one, the one that's after slides over. So let's say I remove the guy at 0, the guy who at 1 goes to 0, and then I can't remove him again because I plus plus. Now I'm at 1. In the minus minus, if you remove something from the end, that's okay because it shifts to the left, so it's going the same direction, so it would never miss any. Rule of thumb, removing, go backwards. Here's a random number generator that I created before, but now I'm adding from 10 to 50. Nice review. 41 inside means 0 to 40. Add 10, we get 10 to 50. I'm going to go ahead and run that and print those, see how they look. All the evens are gone. And here is the random number generator adding an additional 20 things. We're going to move down. Concurrent modification exception. Well, let's see how that one looks. So this is where a for each fails. If you want to change the list, like add some more things, take things out, do all that type of stuff, that's a problem. So let's run it and let's see it. It's going to crash. Let's check it out. Concurrent modification exception. Why? What does that mean? Well, that means you can't add to a list and process everything in the list. Because this is saying process everything in the list while adding to the list. Well, that's going to change the list, but you're trying to process everything in the list. So how do you get everything processed in the list when you're changing the list? That's tough to do. Now you may think add is the problem. It's not. It's not the add that's the problem. It's the fact that you're changing the list is the problem. See, remove, same thing. You can't change the list with a for each loop. So for each loop are very limited then. It's good to do for quick traversing, but it's not good when you have a complex question. If you have something that you have to change the list, do a couple of things here, do a lot of stuff, don't even bother. For each loop is for simple traversing. I'm going from 0 all the way to the end. Remember, it doesn't have an index. Remember, all the drawbacks don't have an index. You know, we can't tell where we are, and it's just doing every single one. It's go forward, it can't go backwards, right? So so for each loops are not good for complex or even any kind of manipulation or algorithm that requires some kind of work to be done to the list. So what we're going to do then, we're going to avoid this if we have to work on the list, and we're going to use the index loop. As a matter of fact, if you use the index loop all the time, you won't run into this problem. But of course, if you see a case where you can use this and get away with it, like you want to print everything in the list, a for each is perfect. Something very straightforward. Last but certainly not least here, list iterator, not on the AP exam, but it's very nice to know. A list iterator was made specifically to traverse the list. What does that mean? Well, that means that the list iterator is faster. It is faster than all these other way of processing stuff over the list, either for each loop or the index loop. It's made for it. How does it work? Well, let me give you an example. So let's pretend that we had a list and it was 1, 1, 2, 3, 4, 5, 6, 7. Let's just stop it right there. This iterator then is going to go right before the 1. It's going to go here. Okay? It's going to be pointing right here where this cursor is. And because it's made right in front of the list. And then when it says, does it have a next one? It has the ability to peek. Imagine, you're standing there and you peek over and you spot a 1 and you say, yes, true, because it's a Boolean. So, oh, it's true? Then print it then. Print the one that you see next. Okay, once you call next, because it's going to be here, has next one? Yes, it sees the 1. Once the next gets called, this thing moves over and now it's at 1. So the cursor is now here, blinking. Comes back up. It says, hey, is there another one? It peeks over. It says, oh, I see another one over here. Yeah, true. Okay, print that one. Once you call next, it moves over here. And then it looks over again as next. So it's this idea of peeking over and moving, peeking over and moving. So it's kind of look before you leap. So what's good about this? It'll never go out of bounds. Because when you get to this point and it peeks over, you say, there's nothing else there. Right? So this can't go out of bounds. Unlike this, that goes out of bounds. The for each and the iterator will not go out of bounds. Okay? So that's one of the good things about this. It's not on the AP, but it's good to see. So let's go ahead and run this and see what we get. Obviously, it's just going to simply print them. So you could see it prints it here. It prints exactly the list that's above, 113, 113, 51, 519, so on. Okay? List iterator. Good, nice, new thing to contemplate, and it's faster. So if you're looking for speed, you want to go this route. Again, this is a processing and traversing array lists. We've seen some errors. We've seen what to look for. Sometimes you go forward, sometimes you go backwards. Outboxing, unboxing. That brings us to the end of 7.3.